Hello everyone! Welcome again to my channel. Math is Fun channel, an educational channel to help you understand what is the beauty and what is the concept of mathematics. And thank you for those who keep on watching the videos that I am posting or uploading or uploaded rather in my YouTube channel. So thank you so much to all subscribers, to all students out there, to all teachers out there also, and those who are struggling in mathematics and who want to develop their skills and their concept about mathematics. So welcome to my channel once again. So thank you so much, subscribers. Please, when you watch this video, before we continue, I want you to click subscribe, click the yellow bell button so that you will be able to be notified once there is another video or new video to that will be uploaded rather in my uh, YouTube channel. Okay, so please click subscribe, share it with your friends, those students or those friends who are really in need of this video. Okay, so thank you for subscribing and hope you will continue to watch the video. Just click subscribe again and the yellow bell button. So now let's start with our discussion. Before anything else, let me remind, or let's have first a review about what is a proper subset, since this is the most, not the most, one of the least learned competency or skill in the set theory. So as I have mentioned, yes, last time or in my previous video, I just want to correct it. When we say proper subsets, it is we consider it a proper subset if a set A is a subset of a set B and is not equal to B when we call A or set A a proper subset of B and write A as a proper subset of B. So to remind everybody about what is a proper subset, let's review first what is a subset. So when we say subset, the concept of the subset is it is a part of a given set. So in a formal definition of a subset, we say set A is a subset of B, written A as a subset of B if and only if every element of A is also an element of B. That's why we call it a subset when something is part of a given set. That's the concept of a subset. Now we go over with the proper subset. So a proper subset, set A is a proper subset of B, denoted in the symbol as you can see there for a while. This one, this symbol shows the symbol of, or it represents the symbol of a proper subset. That means, or again, I'll repeat, set A is a proper subset of B if and only if every element of A is also an element of B. That's why first requirement, it must be a subset. Again, if and only if the first condition, if every element of A is also an element of B, or element of B that is also an element of A if are going to interchange them. Another requirement is B contains at least one element that is not in A. So if we use the rules like the first one, if every element of A is also an element of B, then B contains at least one element that is not in A. So to illustrate that one, because if we are going to just read the definition of a proper subset, it will be difficult for us to understand its concept. What does it mean? So I'll highlight in this given Venn diagram. As you can see, we have the universal set containing the elements of 1, 2, 3, 4, and 5, and also set A containing the elements of 1, 3, and 5, and also B containing the elements of 1 and 3. So as you can see in the illustration, B consists of 1 and 3 elements, and A consists of 1, 3, and 5. And of course, for the universal set, since everything is inside in a universal set, then it consists of the elements 1, 2, 3, 4, and 5, as you can see in the illustration. Now, Now, class, we can say that B is a proper subset of A in this given illustration because there are what? There are elements, at least one element of B that is not, what I mean is there is at least one element of A that is not in B. Therefore, B is a proper subset of A. What element is that? 5. Okay? A consists of 5 that is not in B. That's why B is a proper subset of A because A or set A consists at least one element that is not in B, which is 5. So we can say that B is a proper subset of A. So I hope you'll be able to uh, grasp the concept of a proper subset. So I want you to remember that one. Okay? Did you get me? So again, why is it B is a proper subset of A? Because there is an element of A, at least one element that is not in B. So B is a proper subset of A. Okay, that's it. That's how we define, or that's how we consider a proper subsets. Next example. In the example here, we can say that what? We can say, or we're going to identify a proper subset and a subset. So the given there in the example, we have set A consists of elements 1, 3, 5. Set B consists of elements 1, 3, 2, 3, 4, 5. And set C consists of the elements 2 and 8. So we can say that A or set A is a proper subset of B. Why? Why is it A? A is considered as, or it is a proper subset of C. Why? Because there is at least two elements. What I mean is in B, sorry. Nalibat ko. Again, I'll repeat. In this case, A is a proper subset of B. So A is a proper subset of B. Why? What's the reason, class? Because, look at, I want you to observe the elements so that you can identify why is it it's called a proper subset. Why is it A is a proper subset of B? So check the common elements 1, 3, and 5. Okay. So why is it A is a proper subset of B? Because what? There are elements of B that is not in A. At least one element of B that is not in A. That's why we call it A, or we say that A is a proper subset of B because there is elements, at least one element of B that is not in A. So how many elements are there in B that is not in A? There are two. 2 and 4. Elements 2 and 4. That is not in A. That is why A is a proper subset of B. Another thing also in here is C is not a subset of B. Why is it C is not a subset of B? Why? Because C consists at least one element, which is 8, that is not in the not in the elements of B. That's why C is not a subset of B. So it lacks a symbol, this one, line below. So always remember, so that's how we define a proper, or identify or determine the proper subset of a given set. So always remember, when we say a proper subset, class, do not forget, it will be a proper subset of if A, or set A is a proper subset of B if and only if the first rule. Again, if and only if every element of A is also an element of B. The second condition is B contains at least one element that is not in A. And it is said to be that set A is a proper subset of B. So I hope you'll be able to get it. So I reviewed this one because maybe you got something like you misunderstood the lessons in the previous video about subsets. So I am just making clear of this. Okay, before we go to our main topic this in this video discussion. So our topic in this video discussion will be something to do with the set theory operators. So what have you observed in the picture? You see union operator, intersection operator, difference operator. So these are things that we need to remember in the operations on set. So now let's go over with the operations on sets class. So are you ready? I know you're all ready. You want to learn? Yes. Better to listen. Don't forget to subscribe and share this video to your friends and to your loved ones and classmates, those who are struggling in mathematics, especially in this topic. Okay, so now let's continue. Things to remember about operations on sets. We have what we call, or we use the terminologies union of sets. So when you encounter the word union of sets, what does it mean? Okay, it is represented in the symbol. So please do not forget to remember their representation or notation. It can be denoted in this symbol. So that means that X such that X is an element of A or X is an element of B. So a union can be represented with a preposition or. So again, in higher mathematics, union of sets can be represented by, or in a worded problem, union of sets can be represented by a preposition or. So again, this is the symbol A union B. You can read this one as A union B. So that is union of, oh, what is it? Why is it it's not really straight, the line? Union of sets. Again, union of sets can be represented in this symbol or notation. So do not forget the or that will represent or describe union in a worded problem, or even in higher mathematics like in probability. Another thing also that we need to remember on operations on sets, offsets rather, is the intersection of sets. So this can be represented in this with this symbol, this one. So this is the notation or the formula, yeah, the notation on operations on sets about intersection, used to describe intersection rather. So this is intersection. You can read this one as A intersection B. So on the other hand, we can rewrite it in this or describe it in this way. X such that X is an element of A and I highlight the word and. X is an element of B. So meaning to say, if you encounter in a worded problem under set theory or operations on sets, if there is a word and that describes intersection. Okay, the preposition and determines or describes the intersection of a given set. So do not forget that one. Do not forget the notation and do not forget the preposition used to describe the operations on sets. Again, union used to have as this in its symbol and represented by a preposition or. Intersection of sets can be represented by this symbol and also can be denoted or yeah, can be also described using the preposition and. So if you encounter the word and, that means intersection. If you encounter the word or, then that means union. Do not forget that one and also their symbols. So now let's proceed. The difference of another thing also, the difference of sets. When we say difference of sets, A minus B means A intersection of the B complement. That's the notation, or this is another form or the other form of the difference of sets when we have a difference of A and B or A minus B. So when you have A minus B, that can be represented or can be illustrated in another form of notation, which is A intersection of B complement. So that is, or these are the symbols that we need to remember, or definition that we need to remember in the operations on sets that I want you to remember. Okay, so I hope you will remember this, or the symbols used to describe the operations on sets. So use Venn diagram to depict suitable region for above set operations. So in our next video, we're going to represent the operations using the Venn diagram. So we have a separate lesson on that. So now, set operations. Let's start with the union of sets. Let's discuss each of them thoroughly so that you will build the concept in each operations on set. Let's start with the union of sets. When we say union, again, represented or written as this, the union of two sets is the set that contains elements belonging to either of the two sets. That's why it is represented by a preposition or for the union. And also the equivalent it, as what I've said, in a Boolean operation. Do not just, if you think it's really difficult, the word Boolean, it's Boolean geometry, but never mind, it's not the focus of our discussion. In short, other form or preposition used to describe a union is the preposition or word or. So that means union, or yeah, union, or written as this symbol, as you can see. So example, A is equal to A, B, C, D, and set B consists of elements D, C, D, E, F. Therefore, A union B consists of A, B. You just list all the elements, but make sure that when there is a repeated elements, take it as one, just like C in A and C in B. So when we get its union, we take it as one, C. Okay, even the D. Look at, we take it as one, G. Okay? So, again, one thing that we need to remember in getting the union of sets, we have to take as one when there is a repeated elements in a given set. Okay, so I hope you are going to remember, you will be able to remember that one. Union means it's like you are adding them, but in adding them, you have to consider that when there is a repeated elements rather, take it as one. So note that the set could have been described as A, B, just like what I've said. When you list them, all the elements of A and B to get its union, when you combine them, it will become like A, B, C, D, C, D, where C repeats twice. So take it as one as your final answer. For your D, take it as one also. So this must be your final answer, not this one. Okay? So I hope you'll be able to follow. So that is union of sets. So another example for union of sets, more examples, A, B, C. Sets or elements, or a set containing the elements A, B, C. Union, a set containing the elements of 2 and 3. So just list all since there is no repeated elements between the two sets given. So we'll just write A, B, C, 2, 3. Sir, is it okay if it is like not arranged, not in order? As what I've said in the previous videos, in sets, order is not, or it doesn't matter. It will not affect the result of our elements, or yeah, of our in our sets. So next example, 235 union 357. So we have it here, 2, 3, 5, 3, 5, 7. Since 3 repeats twice, take it as 1, as you can see. 5 also repeat twice. 5 repeats twice rather, so take it as 1. So our final answer now will be 2, 3, 5, and 7. Do not forget to write or to include a pair of braces, okay? So that your answer will not be marked wrong. So now, that's the union. Again, do not forget union means You are combining the elements of a given set. If there is a repeated elements, then take it as one. Another thing also, it is in a worded problem, it is or in other form, it is represented in a or described by a or used to um, or represent or it is represented rather with a preposition or by a preposition or. Do not forget that one. So the concept of union in a normal operations is like you're adding them all or the elements of a given set. Okay, so do not forget that one. So sorry. Oh, what's happening here? Sorry for the advertisement. That's the union. Okay. The other thing also, it's erased. It's not here. There's no title in here. Maybe I forgot the title. Our next operation that I mentioned a while ago, it's about the intersection. I'll just write intersection. So what is intersection of sets? When we say intersection of sets, as you can see in your module, if you don't have module, this is the definition. Simple definition for intersection, as what I've said a while ago. It is represented by a preposition and. That means common elements. Okay, if the set has common elements. So in short, when you are asked to get the intersection of the two sets, then you are trying to look for the common elements. Okay? The elements that are in common to both sets. That's what we call intersection. Again, it is represented by a word or preposition and. So if you encounter the word and in mathematics or in higher math, like in probability or other field of set theory, what I mean in the set theory, then and means intersection. Another definition, a very simple way to define an intersection is it is an operation on sets where we find the common elements of both sets. Again, common elements of both sets. And it is represented by this symbol. Okay? Check. This one, check. And this one, the symbol, check. The symbol is this. Okay? So do not forget it. So you can see it, the symbol. So let's have an example about intersection. Why is it I erase it? I'll write it again. Intersection. Sorry for the noise of my dog. My dog wants to learn mathematics also. Okay, so example of intersection. In the example, you're going to look for the intersection of the two sets. In the first set that we have 1, 2, 3, and then 3 and 4. So again, when we say intersection, what we are looking for? We are looking for the common element, which is, or what is their common element or elements? As you can see, it's pretty obvious, 3. Therefore, their intersection is 3. Okay? So please write it in with braces. Do not forget how you write the intersection because you're referring to the elements of a given set. What I mean, it's a set. Do not forget the braces. If you forgot to write it, then I'll mark you wrong. You have to consider that one, the symbol. It must be inside the set symbol or the braces. Why? Because we are describing the common elements in a given set. Not the element because you are not really as the element, but the common elements in both sets. So it must be under the set. So that's why it must be written or placed in a braces inside the pair of braces. Another thing also, class, another example, 1, 2, 3 sets containing the elements 1, 2, 3, and also a set containing element of 4. So what's their intersection? They're common. So is it possible that there is no common element? Yes, it's possible, as you can see in example number 2. So if there is no common element, then the set is said to be disjoint later on, or it must be, or it is said to be null set or a null set. Their intersection is a null set since there is no common element between the two sets. What about this one? The two sets have common, of course, all members of the given of the two sets are the same with the other. So 1, 2, 3 is the intersection or their intersection. So do not forget the concept of intersection. When we say intersection, that means you are looking for the common elements of both sets. Okay? Represented by the symbol, this one, the symbol, and also in other way or in other field, it can be represented or described by the preposition and, that is intersection. So, and is not only for English. Our prepositions are not only used for English, in English rather, but also in math, especially in the set theory and probability. So now, I mentioned a while ago this joint sets example. As I have said a while ago, when there are no common elements, then we can say that their intersection is a null set, and we call it disjoint sets. So what is disjoint sets? So we will highlight the word disjoint sets. So when we say disjoint sets class, two sets are said or called disjoint if and only if their intersection is empty set. So if the intersection of the sets given are empty or a null set, then we can say that the sets are disjoint, as simple as that. No common element, no intersection. In short, the intersection is empty set rather. So let's have an example. A consists of the elements 1, 3, 5. B consists of elements 1, 2, 3. And C consists of elements 6, 7, and 8. Are A and B disjoint? Look at A and B. Are they disjoint? No. Why? It's there, sir, on the screen. No. Yeah, I know it's on the screen. Why is it A and B is not, or there are disjoint sets rather? Because they are not disjoint because they have common elements which are 1 and 3. Therefore, it is said to be A and B disjoint. So in short, A and B are disjoint sets. They are disjoint sets. They are not rather disjoint sets. Why? Because they have common elements. Sorry, it's like I'm sleepy. I hope you are not sleepy, okay? Still have focus. Again, A and B in this example, they are not disjoint because they have common elements or they have intersection. What about this one? A and C. You try to compare A and C. So A, this is for A, this is for C. Are they disjoint? Yes, sir. Why? Because it's on the screen. Yes. Very good observation. The reason is 1, 3, and 5, and 6, and 7, and 8, they don't have common elements. In short, their intersection is a null set or empty set. That means it satisfies the condition or the definition that of a disjoint sets, which states that two sets are called disjoint if their intersection is the empty set. So since their intersection is a null set, we can say that A and C are disjoint. Okay? So this is the illustration or the Venn diagram to show how disjoint sets go on. How we describe them rather. Describe the disjoint sets. So as you can see, there is no intersection. They never intersect. In short, they have no common. They don't have common elements. That's why we call it disjoint sets. So it's so easy to remember that one, okay? So I hope you'll be able to remember that also. Okay, now let's proceed to the difference of sets. When we say difference of sets, it could be A minus B or B minus A. So let's see their difference so that you will be able to identify there or describe them one by one. Actually, they're just the same concept, but it could be A minus B or B minus A. So let's start. To start with, when we say A minus B, or when we say the difference of two sets, I'll highlight the difference of two sets A and B is the set of elements which belongs to A. I'll highlight this one, which belongs to A, but which do not belong to B. It's in A, but not in B. That's the meaning of the difference of two sets. Then if that is the case, then we can say, class, we can say, audience, that it can be denoted, or in the statement, it can be denoted that A minus, or it can be denoted by A minus B. Again, I repeat, the difference of two sets, rather, A and B, is the set of elements which belongs to A, but which do not belong to B. It is denoted by A minus B. So A minus B means a set of X such that X is an element of a member of A, or a member in set A, and X is not a member of or element of B. So in short, belongs to A but do not belong to B. So the shaded part represents A minus B. Belongs to A but not in B. So the shaded part here, the color blue, that's the answer when we get the value of, or when we solve A minus B using the difference of sets. Another thing also, the B minus A is the opposite thing. X such that X is an element of B and X is an element of, is not an element of A. So B minus A can be represented in this. So the shaded part in here, since we interchange them, of course, the B itself. So belongs to B, which does not, or which do not belong to A. Okay, belongs to B, but do not belong, or does not belong to A. So that is what we call B minus A. So this is again for A minus B, this Venn diagram. This Venn diagram represents B minus A. So that's how we describe the difference of sets. Do not forget, A minus B means belongs to A but does not belong to B. B minus A means belongs to B but does not belong to A. So I hope you can manage. So that's really the not really part, yeah, part of the operations on sets. So set operations, the difference. We can now formally define what is the difference of sets. So the formal definition, we already um, use this one, the definition, this symbol, A minus B, represents to the difference of two sets. Again, the meaning of A minus B means X such that, using the set builder notation, X such that X is an element of A and X is not an element of B. Belongs to A but does not belong to B. Further examples. Okay, it's very important to apply the concept here in the examples below. So 1, 2, 3 minus 3, 4, 5. So use the concept A minus B. Belongs to A but does not belong to B. So belongs to A, what numbers belongs to A that does not belong rather to B. So this one and 2. 1 and 2 belongs to A, which is not, or which does not belong in here. So the answer is 2. Okay? What is in A, what is in the first given set that is not in the second given set? That's the meaning. So the answer in here is 1, 2, because only 1, 2 belongs to the first given set, which is not, or which does not belong to the second or other set, 3, 4, 5. What about this one? AB minus 3, 4. So easy, right? AB does not belong to 3, 4, but it belongs to the first set. So the answer is AB. What about this one? 1, 2, and null. Okay, 1, 2 minus null is the set itself, 1, 2. Okay? Because 1, 2 belongs to A, let 1, 2 be your set A and the null be your set B. Therefore, 1, 2 is the set is the are the elements of A does not belong to B or to the null. So that's it. So easy, right? So I want you to remember this one, how we get the difference of the two sets. Okay, now more examples. See, we have more examples. I hope you'll be able to understand it right away, or you will already, or you'll be able to master this concept. I know you can. Can you do that? Yes, you can. I know. I believe in you. So example, the universal sets, we have 1, 2, 3 to 10. And set A consists of 2, 4, 6, and set B consists of 1, 2, 3, 4, and 5. Again, you cannot have the difference of two sets when you don't define your universal set. Make sure that you have your universal set before you do the operations on sets with respect to the universal set. Okay? Now, that is just a reminder. Find A minus B and B minus A. So A minus B, what is in A that is not in B? A consists of 2, 4, 6. 2 is in B, yes. So X. And then 4 is in B, so X. But 6 does not belong to B. Therefore, the answer is 6. A minus B is 6. Check! Okay? No question? So clear? Very clear. Let's proceed to B minus A. B minus A. So belongs to B. That is not in A. There is 2 in A, so there is 4. So meaning belongs to A, 1, 3, and 5 does not belongs to B, does not, which does not belong to A. Therefore, we have 1, 3, and 5 left in B. Since 2 and 4 belongs to A. Okay, so our answer is 1, 3, and 5. Clear? I hope you got it. So now, after we define the the difference of sets, or two sets rather, we will now, or we can now define a complement of a set. So when we say complement of a set, as you can see in the definition in there, complement of a set means, sorry, it's very noisy outside because the dog wants us to, they want also to learn a complement of a set. That's why they are barking. See, the dogs are interested, and I hope everybody are also, or all of you are also interested to learn about complement of a set. I know you too. That's why you are in my channel. Now, complement of a set, when we say complement, that means it is the set of elements which do not belong to the set being complemented. I'll repeat, complement of a set is the set of elements which do not belong to the set being complemented. Equivalent, this is equivalent to the word not. When you hear the word not, or that refers to complement. In short, complement of a set can be written as prime. So when you say A prime, that means complement of A. So again, it is again complement of a set has several symbols. We have a prime, or it can be written as prime, like this, or a superscripted C. What is superscripted C? This one, A to the power of C. So A prime means complement of A. So that's how we represent complement of a set as a symbol. Example, make sure when you use complement of a set, you have to define first or respect the universal set. So if we have the universal set given A, B, C, D until Z, A, B, C, D, E, U, V, W, X, Y, Z, this one, and your A is A, B, C, X, Y, Z, and your B is consists the elements of A, B, C, D, E. Then the complement of A, so what's the complement meaning? the set of elements which do not belong to the set being complemented. So if we have A prime, that means, what I mean, when we get the complement of A based on the given, what's our answer? Sir, it's there. Yeah, I know it's there. It's here rather. So I want you to just observe first the answer so that you'll be able to identify how to get the complement of a given set. So the complement of A is D, E, U, D, E, U, V, sorry. Why did I encircle the B? Tulugon na si sir. I'm just joking. I'll repeat, we will get the complement of A. So again, you base it on the universal set. That's why I said a while ago that when you get the complement of a given set, you have to respect the universal set. So there is A in the given set A. With respect to the universal set, we have B, we have C, we have, what else? Try to help me. X, okay. Y, yes, there is Y. We'll just mark them. Z, okay, mark Z. Okay, what's left on the universal set? This, the D, E, U, V, W. That's why the complement of A is D, E, U, V, W. This is what I said a while ago. The set of elements which do not belong to the set being complemented. So which elements or what elements does not or do not belong to set A when we get the complement of A or A prime or A superscripted C. Okay? So, that's how you get the complement of a given set. This one, what about for B? So, for B, why is it our answer is U, V, W, X, Y, Z? Why is it that the complement of B are the elements U, V, W, X, Y, Z? Look at. Because, how to get it again? Okay, first we mark those who have the common elements rather, not have common, the common elements in a given set to the universal set. B, yes, B. C, yeah, they have C. They have D, okay, mark D. E, yes, mark E. Therefore, what is left are the elements that we can have as the complement of B or set B. That's why our answer is U, V, W, X, Y, Z. Again, when we say complement of a set, that means set of elements which do not belong to the set being complemented. So I hope it's very clear or we are clear on that. So the complement of sets in a formal definition for the complement of a set, as you can see, I'll just encircle this one, they are just the same. So if you see this notation, that means complement of A. This one, another A prime. This one is A superscripted C. This one is A prime. And we can also rewrite these two symbols as we have it here as this symbol U minus A. So if we use the concept of a difference, then when we talk about complements of sets, then it's like universal set minus A. So we're going to look for the elements that are not in A or set A. Just like here, the universal set is 1, 2, 3 to 10. Then our A is 2, 3, 5, 7. And our B is 2, 4, 5, 6, 8, 10. Then if we get the complement of C, that means universal set minus A. So universal sets, we have 1 to 10, this one, minus 2, 3, 5, 7. So eliminate 2, 3, 5, 7, 2, 3, 5, 7. We mark it. So what's left will be will be the answer or will be the complement of A. So we have it 1, 4, 6, 8, 9, and 10. Okay? So I hope you'll be able to grasp the concept and got it correctly. So the complement of sets means the set of all elements in the universal set which are not in a certain set. That's why we denoted it as A prime. So as example there, universal set 1 to 10 and our A is 1, 2, 3, 4, 5. Of course, our complement of A is not in A, which is 6, 7, 8, 9, 10. Right? But we will must subtract it like that. Okay, so what will be left will be these elements. So that's our complement of A. Okay. So I hope everybody got it correctly. What I mean, the concept. So that's how those are the lessons that we have in this video discussions about the operations on sets. Do not forget the notation, the symbols, and how we operate them or use them as our operations on sets. So thank you for listening, everyone. I would like to commend the people behind this. Okay. So these people, the Team 7 in Naruto, joke lang. Okay, so that's it. Thank you so much for listening, for continuing to support my channel. So please, if you like this channel, if you learn something, share it to your friends, to your classmates, especially those who need this lesson so that they will be able to understand things about the operations on sets. I know this is more abstract. I'm trying to make it more like in a real life scenario. Yes. Okay, so if you like it, if you like the video, just click subscribe and click the yellow bell button rather, so that you'll be able to be notified once there is another video to be uploaded in my YouTube channel. So click subscribe, share, and comment if you have some questions. Thank you so much. Have a nice day, everyone.